The following KQED production was produced in high definition.
Artificial intelligence. The phrase may send a shiver down your spine, suggesting images of Terminator robots bent on world domination.
Listen to me very carefully.
But today's intelligent robots, advanced as they might be, are more like toddlers than Terminators, trying to grasp the world around them.
That wasn't great. So it turns out that getting robots to recognize things from a picture is one of the most difficult things for robots to do. So we often end up writing fairly large amounts of software to, say, recognize what a computer mouse is or what some other object is.
To cope with complex tasks like object recognition, top AI researchers like Stanford University's Andrew Ng wrestle with problems in computer science, cognitive psychology, math, and even philosophy when trying to demonstrate intelligence in a robot.
When you think about human intelligence, I think people can do a lot of things, and when robots start doing some of the same things that we think of as requiring cognition or reasoning or thought, that's when we think of our robots as starting to be intelligent as well. For example, if you have a robot recognize a new object it's never seen before, or if you have a robot able to navigate a building that it wasn't explicitly programmed to navigate, these are examples of what we think of as artificial intelligence.
Have it your mode.
Building a robot that can recognize new objects and size up new environments. It's all in a day's work for STARE, the Stanford Artificial Intelligence robot.
On the STARE project, our goal is within a decade to develop the technology to make it useful to put a robot in every home. Many of us spend lots of time today on household chores like tidying up and cleaning and cooking. And on the STARE project, I'd like to build a robot that can do many of these things for you.
Before STARE, there was Shaky, the first artificial intelligence robot, created in 1966 at the Stanford Research Institute in Menlo Park. Since Shaky, computers have gotten far more nimble. Why hasn't AI made similar gains? Well, with AI, the intelligence lies less in the hardware and more in the software. And writing the code, or algorithms, to make machines smarter has been tricky.
The computer algorithms really lie at the heart of making the robot smart enough to carry out all the tasks we want it to do. To implement these algorithms often requires that the programmers have a deep understanding both of computer science principles as well as of robotics principles, how to move things around and what different sensor readings are telling you about what's out there in the world.
And looking at the world through STARE's eyes offers a new perspective, or more accurately, a whole new dimension.
When you're building a robot, you can often endow it with extra sensors that we as people don't have. One of the extra sensors we have on a robot is a laser scanner. And what it does is when it's trying to figure out the three-dimensional shape of something in front of it, it plays a laser over what's in front of it. And by seeing where the laser beam falls and doing some math, it can actually compute the 3D position of a lot of points in front of the robot.
But seeing the objects around it is only part of the challenge. STARE then has to be able to recognize them if it's going to interact with them.
So the way the robot learns to recognize objects is we actually show it lots of examples of, say, bicycles or coffee mugs or slippers or whatever. What a computer actually sees is a lot of numbers like these, and it tells you for every pixel in that picture exactly how dark or gray it is. And so a small number is a light pixel and a big number is a dark pixel. And the job of a robot is to look at a lot of numbers like these and figure out if there is a sleeper in those numbers.
And when it comes to learning, it turns out that even machines can respond to a little positive reinforcement. Here, numbers function as rewards.
So one way of thinking about this is it distills down the notion of rewards down to a mathematical formula in which we use a number to tell the robot how well it's doing. And so every time your robot does something good, the reward function outputs a large number, and that tells it has done well.
AI is about more than making robots smarter. It's also about getting computing applications like those used on the internet to think, even reason, more like humans. Daphne Kohler of Stanford University is using AI to make image searches more accurate by teaching the computer to understand context.
A computer system by itself is pretty dumb. It doesn't know things that are obvious to you and me. And so everything that a computer system knows is going to be something that you have to either tell it or better, and this is the revolution that we're undergoing, have it learn by itself by seeing enough examples of real images. So here's an example that we are using for outlining giraffes. Initially, what the system is given is a bunch of examples of a giraffe that are outlined for it. For each of these dots, there's actually a machine learning algorithm that learns to rank different pixels, different regions in the image and say, this is a plausible place for this purple dot as opposed to this, which is not so plausible. And the algorithm figures out that this dot on this giraffe corresponds to, is the same kind of position as this dot on this giraffe. It learns how to make these distinctions, just like a human child, once it understands what giraffes look like, can understand the difference between standing up and leaning down with 2 or 3 examples. The computer system can do the same thing.
Working with AI is like teaching a child. It requires a lot of patience and flexibility.
So obviously here the algorithm made a mistake. It's a pretty bad mistake. If you actually look closely, you can try and understand why it made the mistake. There's actually sort of contour lines here where the zebra is confusing it and it's looking like it's seeing a leg. And so there's actually 2 types of learning that one can do using an example like this. One is training the algorithm and one is training us, the person designing the algorithm.
But even if a machine can learn from mistakes, is that really intelligence? Will there ever be a truly intelligent machine, one that rivals us in its ability to reason?
The human brain is maybe the most amazing computer that we know of in the entire universe. The brain has 10 to 11 neurons. That's a 1 followed by 11 zeros. That's a huge number. And today, we barely understand how the brain works.
But how the brain works and its structure may hold the key to a new kind of thinking machine. Just ask Dharmendra Moda, an IBM engineer at the Almaden Research Center in San Jose.
If you could map out the blueprint of the wiring diagram of the brain, we could then use the wiring diagram of the brain as a starting point to create a new generation of computers.
Dharmendra's road to reverse engineering the human brain has begun on a slightly smaller scale.
One of the achievements of my group was that we were able to map a rat's brain onto a modern-day existing supercomputer. What we are looking at here is a simulation of the rat's brain. The top 2 panels represent the right hemisphere. The bottom 2 panels represent the left hemisphere.
This model of rat brain activity is an important step in their quest to build an artificial brain, where processors may function like neurons and synapses.
Imagine taking this visualization and underlying computational engine becoming the new paradigm in computer science.
What kind of world does this herald? Will thinking machines soon exert significant control over our day-to-day existence? Probably not. While the hardware exists to carry out such brain simulations, the software to make the cognitive computer reason and multitask like a human brain remains elusive, for now, that is. But in the field of AI, it pays to think big and be patient.
I think that of all the things we could be spending our time doing, what could be more exciting than trying to build systems that are as intelligent as you and I are? And whether it'll take us 10 years or 50 years or 100 years to figure out, I don't really know.
Here is your stapler. Use it wisely.
But I'm an optimist. I do believe that someday computers will be as intelligent as you and I are.
Open point.
Keep Quest free. Discover more and donate at kqed.org/quest.